Hey guys, welcome back. Today we're going to be looking at radicals, and you should have this handout in front of you. And let's take a look here. So it says radicals are the inverse operation to powers, and that's true. We should kind of remember that from doing x squared and a square root. Those were inverse operations, and a square root would cancel out a squared. If you remember from solving quadratic equations. Hey, and by the way, do you know if you have a root like this, we call it a square root, and there's no number for the index, whereas here we have some number right there. It's an n, but it can be any number. Well, pretty much any whole number. And if you don't see a number here, it's actually an invisible 2. In case you didn't know, right? A square root is our second root, and it cancels out with the squared. And what we're going to be looking at here is radicals that are bigger than just a square root. Just like in our polynomials unit, we looked at exponents that were bigger than 2. Now we're going to be looking at roots that are bigger than 2. That's kind of the gist of what we're doing. And it gives us a reminder here, right? This is the definition of an exponent. Look, x to the power n means we have whatever base x, and this is multiplied together how many times? N times. Right? So if n is a 5, we'll have 5 of them multiplied. If n is 100, we got 100 of them multiplied. And it says here, in order to evaluate the nth root, we would need, well, there's two ways we're going to do it. We're going to do it with a calculator and without a calculator. And to do it without a calculator, we're going to need a list of perfect powers. And what are perfect powers? Well, we actually worked with a list of perfect squares in our unit on quadratics. Remember all those numbers? 1, 4, 9, 16, 25, etc. Those were our perfect squares. Square is exponent of 2. Now, if we have a bigger exponent, we can also generate a new list. Say, for example, perfect cubes or perfect fourth powers. And you should also have a copy of this list here. We're going to be working with this list, so you should have one of these. This here is a list of perfect powers. Look, we've got we've got a total of 5 lists. These are squares, these are cubes. Once the exponent gets above a 3, we don't really have a special name for it. So these are perfect powers of 4, powers of 5, powers of 6. So here's a list of perfect powers of, up to powers of 6, all of the numbers up to 1,000. And so if we're evaluating a root or simplifying a radical without a calculator, we can use the list of perfect powers. All right, so here's an example. Let's do example number 1. And what we have here is the cube root of 125. Okay, so the number that we're looking for here, we got to figure out what this is. And that's going to be the exact same number that works here. What number times itself 3 times equals 125? Right? So fill in the blank. These are blank spaces. You got to fill in the blank with the exact same number in each space. I wrote 3 spaces because the root is a 3. Okay. So you might be able to think about this and come up with a number here. but we have a list of powers that we can look this up on. So let's go back to the list. All right, cube root of 125. So this is how you do it on the list. If this is what we're trying to do, here we go. 125, and it's a cube root. So because the root is a 3, I'm only going to look on the list of powers of 3. So for this problem, I'm going to ignore this list and this list. This is the one I'm going to focus in on because this is powers of 3. You guys see this? Now, is 125 on the list? It sure is. Right here it is. And this tells us 5 to the power 3 equals 125. So over here, right, this is the number that makes this true. 5 times 5 times 5 equals 125. You could check that on your calculator if you want. So therefore, that means the third root of 125 is a 5. And that's our answer there. Okay. So hey, look, why don't you try this one here? Okay. We're gonna go through this together. I'm gonna do the examples on the left, and you can try the examples on the right. So try the one on the right and see what you get, and then we'll look at example number 2. All right, so it asks us here, how can we use our calculators as a tool to evaluate a perfect root? Yep, that's right. Calculators, hey, they're a wonderful tool, aren't they? And they can definitely evaluate actually any root, not just a perfect root. But let me show you how you can evaluate any root on a calculator. Now, let's see. I'm going to show you here on Desmos first, and then I'll show you. I don't have the handheld TI-30 graphing calculator. I don't have one of those with me, but I'll show you on a picture how to do it on there first. So, all right, and let's just do this problem right here, which we just did. First thing we could do on a calculator is just confirm, right? Does this work? 5 times 5 times 5. So let's do that. So on Desmos here, I can do 5 times 5 times 5, and the answer is 125. There it is. Also, I can write this as 5 exponent 3, which means the exact same thing. 5 times itself 3 times, and we get 125. Okay, but now how do I evaluate the third root of 125? That's really what we want to do here. So I want 125, but I want to take the third root of that. Well, to do this, you're going to need to open up the keypad down here. Now the keypad, it has some operations here, numbers here, but over here, this button functions. When you click that, it opens up a long list of all kinds of different functions. And if you scroll all the way down to the bottom, this is the one we want. You see the radical symbol with the N? That's what we want. And then I come back over here and I can type in an index of 3 for the root, 125 on the inside, and take a look. It gives me an answer of 5. So that's how we can do it. By the way, you could also evaluate using a calculator, right? Desmos or your handheld calculator, the equivalent form. So this is radical form. What if we switch this to exponential form? So our base would be 125, and then our exponent would be a fraction. What would that fraction be? 1 over 3. And take a look. When we evaluate that, we get the same thing. We get an answer of 5. So Desmos is a great tool. but so is the handheld calculators that we have. Let me just show you how to do it on there. Let's see. I think I've got it right here. Here it is. So if you look closely, there is an nth root on this calculator, although it's actually, instead of an n, they use an x. You guys see this right here? This is it. Now, you should be pretty familiar with this one. We've been using x squared, and then when we were taking square roots, we hit the second button and we got square root. Okay, well, right above the x squared button, we have our exponent button. This is how we put in any exponent, not just a squared. And then this right here is how we're going to put in any root that we want, not just a square root, but any root. So the way you're going to type this in is you have to start with the index of the root. So let's see, this is what we're typing in. If we're doing the cube root of 125, we start by typing in a 3. And then to get the root, we have to hit the second button, right? So we hit the second button, then we hit this button, which of course gives us this function here. And then we type in 125. And what it'll look like on your screen, on your calculator screen, you'll have the 3. And then after you do second and hit that button, you'll get a radical with an X. And then you type in 125. Then you hit enter. And guess what? It's going to give you the same answer, 5. So that's how you can do it on the calculator. Okay. And I guess while we're doing this, let me just tell you, if you want to do exponential form on the calculator, so let's say you want to type in this, the equivalent expression in exponential form. When you type this in, 125, then you hit the exponent button. And then what you have to do here is you have to put your exponent in parentheses. So using this calculator, if you have like a fraction in the exponent like we do, you have to put it in parentheses. You do parentheses 1 divided by 3, close parentheses, then hit enter, and you'll get the same answer of 5. So that's how you evaluate it with Desmos and then with our handheld calculator. And then let's see. Oh, let's go here. Okay, so let's go ahead and take a look. All right, example 2 here. The cube root of 216, and we want to see what this is equal to here. Well, let's start by checking our list of perfect powers. And again, this is what we're doing. Cube root of 216. So since the root is a 3, I'm only going to look at the list of powers of 3. That's this list. You see this list has all exponents of 3. That's the list I'm going to focus on. For this problem, I'm going to ignore those lists. Now, cube root of 216. Is 216 on the list? It is. Here it is. Okay. 6 cubed is equal to 216. Therefore, the cube root of 216 is equal to 6. So this is another one where the answer is a whole number. So let me come back over here. Answer is equal to 6, and we're done. Okay, just like we had here with the cube root of 125 was a 5, cube root of 216 is a 6. Those happen to work out and give us whole number answers, but that's not always the case. Sometimes, and matter of fact, most of the time, for if you just take a random number and you take its cubed root, it's most likely going to be a decimal value. So I think we're going to see some of those coming up. But here it's a whole number. That's our final answer. Okay, next one, example 3. And here we've got the fourth root of 162. So index of the root is a 4, 162. Let's do the same thing. Let's take a look at our list of perfect powers. Fourth root of 162. All right. Now notice here the index of the root is a 4, so I'm only going to be concerned with the numbers on this list. These are exponents of 4. Those match up with the root of 4. So for this problem, I don't care about this list or this list or these. I'm just focusing here. And let's see, is 162 on this list? And we see that no, it's not. We've got an 81, and then the next perfect power of 4 is 256. So 162 is not on the list. So what we're going to do then is when we have a number that's not on the list, this means when we evaluate it, the final answer is going to be a decimal. It's not going to be a whole number. And we're going to do two things. If you remember when we were working with square roots, we wanted to evaluate it and get a decimal rounded to 3 decimal places. That was our approximate decimal value. And we also at the same time wanted to get an exact simplified answer. So we're going to do the same thing here. We could start right away by evaluating this on our calculator. So let's just see here on the calculator. Fourth root of 162. And so let's see here. Let's go over to Desmos. Now you can do this on Desmos. You can do this on your handheld calculator. If you're doing it on Desmos, remember you need to click the keypad, click the functions button, scroll all the way down. Here it is, nth root. And now we can type in the index of our root was a 4, 162, and here's our answer, 3.567. You know what? That should kind of make sense because look at this. This is about 3.5. If you look over here on this list, 162 would be right here, 162, in between 81 and 256. So it makes sense that its fourth root is in between 3 and 4. 3.5, what was it, 67? I'm just going off memory. 3.567. That's going to be our answer, but let's not forget to round. So I want you to do 3 decimal places, but we're going to round, so I have to look one place further. To the right of the 7, there's a 6. So that means that the 7 is going to round up. So 3.567, one more digit is a 6. So that means the 7 rounds up to an 8. So 3.568 is going to be our approximate decimal answer. So this is actually an 8. So let me come back over here. Approximately equal to, squiggly equal sign. That means approximate. Anytime you round your answer, you got to do the squiggly equal sign. 3.568. Okay, that one was kind of easy. The calculator gave it to us. Now what we also want to do is simplify this to get an exact simplified root. So the way that's going to work is this. Let's come back over here. And looking at this table of fourth powers, our number is 162. So we're going to see if any number on this list is a factor of 162. 162 is not on the list, but are there any factors of 162 that are on the list? Now, of course, it can't be a number bigger than 162 because there's no way that a number bigger would be a factor. It has to be a number less than 162. So what I'm going to do is I'm going to start by checking the biggest number on the list that's less than 162, and that means 81. So I'm going to check if 81 is a factor. And the way we're going to check that is by dividing. So I'm going to do 162 divided by 81. If I get a whole number answer, that means I found a factor. If I get a decimal answer, that means I did not find a factor, and I have to go to the next number down the list. So basically check 81. If that doesn't work, check 16. If that doesn't work, you never check 1 because 1 doesn't simplify. So if none of those work, that just means that the root is already simplified and it can't be simplified any further. Well, let's start by checking 81. I'm going to do this on the calculator here. Decimal, so 162 divide by 81. And what do you know? We get a whole number. Check right here. 162 divided by 81 is a 2. That means 81 is a factor. So this is what we're going to do. We're going to factor this guy into two separate roots. Now these roots still have to be fourth roots. So the 4 is going to stay there. And we factored 162 into 81 and 2. Now I'm going to put the number that is the perfect fourth power, meaning the number that was on the list. That's 81. Put that one first. 81 goes here. 2 goes here. And then the next step is this. We can evaluate this. Since 81 was on the list, this is going to be equal to a whole number. Let's go back and look. 81 is on the list. It's a factor of 162, and its fourth root is going to be a 3. So this is what we're going to have here. The fourth root of 81 is equal to 3. That's what we get from this table. So over here, this is going to change into a 3. And this is just going to come down. So here we'll have 3 times the fourth root of 2. And you know what? This here is our final answer in simplified form. And if you want to double check your work, this is how you can check at the end that it's correct. Let's type this into our calculator. And if we get this exact same decimal, that means we know that we know that we did it correctly. All right, so let's see here. Let's see, 3 times the fourth root of 2. That's what I'm going to plug into my calculator. 3 times the fourth root. Okay, let's go back over here to the functions menu. Fourth root of 2. Here we'll type in 81. Oh, I typed in the wrong thing, didn't I? I want the fourth root. I put in a 2. All right. That's why, look, this 27 definitely does not match with this answer. But when I change the root, let me fix this here because this is a mistake. This is not supposed to be a square root. It's supposed to be a fourth root. Put a 4 there. Oh, and you know what? I made 2 mistakes here, didn't I? This is supposed to be a 2. Okay. All right. I see it now. 3 times the fourth root of 2. Forgive me. All right. 3 times the fourth root of 2. Now it matches. Hey, but you know what? That was a great example, right? Because each time I was looking at this number down here and I was saying, geez, it's not matching to this. So it's no good. And then I went back and said, oh, yeah, I typed it in wrong. I had to go back and look at my paper. This is the correct simplified form. And we can see now these decimals match exactly. 3.56, round that up to an 8. 3.568. This is our final answer in exact simplified form and in decimal form. All right, let's keep going here. Example number 4. Now, take a look here. Not only do we have a number, we also have a variable. Okay. And I'll show you what to do here with these. We're basically going to treat each of these separately. We're going to try to simplify the fifth root of 243 and then the fifth root of the variable, and then we'll put it back together, see what we get. And to be honest, when you're doing one like these, actually the part with the number can be the more challenging one. The one with the variable, once you figure out how to do it, it can go kind of quickly. So let me just show you here. So first step is we're going to do this. Split this up like this. fifth root of 243. And then we'll have over here fifth root of x to the power 32. All right, so let's just do this first. Fifth root of 243. Let's check our list. You could also go straight to the calculator with it, but if you have a list of perfect powers, we can check here. Now, let's see. What do we got here? Fifth root of 243. And since the root is a 5, this is the list that I'm looking at. Powers of 5. And guess what? There's 243. It's on the list. So this is telling me that the fifth root of 243 is equal to just a 3. So this is gonna change to a 3. Right here. This piece just becomes a 3. So that one was pretty easy. Now, what do we do with our variable? You know what? Let me show you, and maybe I'll bring this over here just so I have a little bit more space. This is what we're going to do. A root of 5 is going to cancel out with the power of 5. So I'm going to use an exponent rule to break this down into multiple factors. And I'm going to try to find as many factors with an exponent of 5. So look, x to the power 32 could be written like this. X to the power 5 times x to the power 5 times x to the power 5. Okay, so what am I doing here? I'm going to use an exponent rule. Remember, the exponent rule says when I multiply and the bases are the same, the exponents add. So far, if I add these up, 5 plus 5 plus 5 is a 15. But I got to keep going until it adds up to a 32. So I'm actually going to do some more. Times x to the power 5. And now if we add up all of our exponents, that's a 20. That's a 25. That's a 30. So I want to try to get as many 5s as I can. At this point, you add up all the 5s, it's a 30. So here, my last one has to be a 2. Okay. And then this is what's going to happen. All of these where the exponent matches with the root, right? So the root is a 5. Here we got exponents of 5. All of these are going to effectively cancel out, and each of those x's is going to come out in front like this, out in front of the radical. So let's see, how many is it? 1, 2, 3, 4, 5, 6. So I basically have 6 x's. 6 x's there. Because what happens is exponent of 5 cancels with the root 5. Exponent of 5 cancels with the root 5. Now the only thing that's left over is this piece. So the x squared is going to be the last and only thing that stays inside of the radical. And now let's simplify this. How many x's do I have here being multiplied together? 1, 2, 3, 4, 5, 6. So this is x to the power 6 times the fifth root of x squared. So let me just bring that over here, put it together with the 3. So this whole piece simplifies to x6 on the outside of the radical, and then x squared on the inside of the fifth root. There's our final answer. Alrighty, a last one here is example number 5. And what we've got here, cube root of 320 times x squared times y to the power 6. So we've got inside of the radical, we've got a coefficient, a number, multiplied by 2 different variables. All right, well, we're going to do this one similar to what we've done here. We're going to split it up. So let's do this. Cube root of 320, and then we'll do that times cube root of x squared times cube root of y to the power 6. Let's treat each one of these on their own, And let's start right here. Cube root of 320. Let's see here. Okay, cube root of 320. So I'm only looking at this list, powers of 3, and 320 is not on the list. It's not there. Here's 340, here's 216. 320 would be like right in between, which means that decimal value of the cube root of 320, it's going to be 6 point something. But really, what we want here for this problem is the not the decimal value, but the simplified radical. So I'm going to check for factors. I'm going to see, are any of these numbers a factor of 320? And I'm going to start with the biggest one, which is a 216, right? The biggest one that's less than 320. So check 216, see if it's a factor. If not, go to 125. If not, go to 64. I'm just going to go down the list like that. So let's do that right now with our calculator. I'm going to use Desmos, and here we go. So 320 divided by 216. And notice here I get a decimal, which means 216 is not a factor. Okay, so I could cross that off the list. That one didn't work. Let me check 125. Divide by 125, and again I get a decimal, 2.56. Therefore, 125 not a factor. Okay, let's check 64. Divide by 64. Oh, look at this. We found a winner. Okay, this here is equal to a whole number, not a decimal, but a whole number. So that means 64 is a factor of 320. Specifically, 64 times 5 makes a 320. So now we can come back over here, split this guy up. So this is going to split into two roots, the cube root of 64 and the cube root of 5. And note that I put the 64 in front. Whatever number is on the list, the 64 was the one on the list. That's the one you want to put first because that's the root that's going to simplify to a whole number. Okay, let's do that. Let's look back at our list. Cube root of 64 is going to be just a 4. So that's what we'll put over here. Cube root of 64 turns into a 4. The cube root of 5 stays in the root. Okay, so we've got that. Now, let's see. Next one here is here. Cube root of x squared. Now, if your exponent inside of the root is less than the index of the root, you're not going to be able to factor anything outside of the root. Okay, because 2 is less than 3. So you know what that means? This whole thing is going to stay unchanged. It's going to come down. So we've got times 3, third root of x squared. And then the last one here is y to the power 6. Okay, now I could split this up, right? This is what I'm going to do here. Cube root of y to the power 6, and I want to write it with exponents of 3. 6 is greater than 3, so I could do this, y to the power 3, and I could do this again. Remember, what I'm doing here is I'm going to write this out with as many y's until these exponents add up to a 6. So 3 plus 3 is a 6. So this is what it's going to be here. And then look, this and this are a match, so they cancel, and the y comes out of the radical. Same thing here. The 3 and the 3 are a match, so they cancel, and the y comes outside of the radical. Nothing left inside of the radical, so that just becomes a y times y, which is y squared. So now let's put all the pieces together. These are the pieces here, here, and here. The stuff that's on the outside of the radical is this 4 from right here. So I'll put the 4 outside. Now from here, there is nothing outside of the radical. So nothing on the outside. That x squared is on the inside. Here, this y squared is on the outside. So I'm going to put that right here, y squared. And then after that, I'm going to put my radical, my cube root of what was left on the inside. Well, there was this 5 here, and there was this x squared there. So that's still on the inside of the radical, 5x squared. Final answer. There it is. Okay, so look, this is going to take some practice, which is why I've left these over here on the right side of the page for you to try. You'll see there's some more problems for you to try. So give these a try, give it your best shot. Use your list of perfect powers, use Desmos, use your calculator, and see what you come up with.